morning. Today for the LIBD RSETS Club, I'm going to present about some updates to biocthis related to the GitHub Actions workflow that this package can help you create. Now, I labeled it as an advanced session because some of these things involve like code you might want to be running if you're developing a package. But like some of the actual code you'll see is like in some sense more basic Linux code. Cool. So biocthis is a package that I made a few years ago that helps you create other packages, other R and Bioconductor packages. One of the functions that it has is this function called use GitHub action, which I guess the website is loading. Sorry, over here. Let's see. Use by a GitHub action. This function over here is going to create a file that will then allow you to have GitHub Actions check your package on Linux, Windows, and Mac. It tries to simulate a lot of the checks that you get from the single package builder on Bioconductor. And it's helpful for developing a package before you submit it to Bioconductor to make sure you're compliant with like most of the things they ask of you, as well as later on, once you've made the package, to make sure that any changes that you make don't break the package, stuff like that. Otherwise, you would need to run a lot of these checks manually on your computer. And you might not have access to a Mac, a Windows, and a Linux machine to be testing everything. So several of us here have used it in the past, or actively still using it for checking our packages. Now, let's look at the summary notes of what of these updates for version 1.17.4. Over here, I say that like, well, it still creates that YAML file, but now it's going to have the options of setting the Bioconductor version. You can either set it to Bioconductor-release or Bioconductor devel, or a specific number in the x.yy format, such as like 3.20. Now, the idea here is this YAML file now can be as static as possible across Bioconductor release versions. So if you set it to Bioconductor release or Bioconductor devel, it will automatically figure out what is Bioconductor release or Bioconductor devel at the moment that it's running the GitHub Actions workflow. This, in theory, is going to make it easier for people because you won't need to be updating this YAML file every time there's a new Bioconductor release. Of course, you might still need to like run biocthis and use biocthis GitHub action if there's other things that have changed in the GitHub Actions workflow over time. But like hopefully that will be even less frequent than what it has been. Currently, like every time there's a Bioconductor release, you have to like rerun this function on all of your packages. And I think I have like 17 or so packages at this point that I'm either a maintainer or a contributor. So that's like a lot of, running the sync command on a bunch of repositories and stuff like that. Something that, okay, so those are the changes. And here I have like an example repository. This is a special IBD repository where I ran this function after the changes, and you'll see like a bunch of things. We'll walk through all of these changes like in a little bit more slowly throughout the session to understand how I implemented all these things. But over here, you can see at the top, there's now this Bioconductor version option. And here I set it to biocthis release. And I said, like, these are the valid options. And then as a user, you're not going to have to change much more besides this. I'll explain like the rest of the code in a little bit. Now, how was I able to implement this? Well, I was reading something else, not necessarily thinking about updating biocthis, when I ran into this website over here that explains dynamic matrix generation. So this is when you have one job on your GitHub Actions workflow. In this case, they have a job with the name build, and they said that this job is going to run on the latest version of Ubuntu, and it's going to create some outputs. It's going to create a matrix output. From where? Well, from this step called set matrix. Under the list of steps that this job has, they have an ID here set, or a step called set matrix. From the outputs of it, it's going to have a matrix table, and that will be then the output matrix for the actual build job. Now, if you look at what's happening inside of that step, they're creating, again, the object matrix. The rest of it is like actually like a JSON syntax for specifying like a little like set of options. So here they're saying like under, and they're going to name something called include. Inside of it is going to have the value for operating system, which will be Ubuntu latest. You'll have a value for this node, which is set to 20. And they're exporting all of this into the set of output, into the output for the GitHub Actions workflow, such that then like if you say like what is the matrix value of that output, well, it will be this like JSON syntax over here. So all of this then is setting a little like JSON matrix that then their second job called test depends on the first one called build over here. And it will read in from the job called build, sorry, from the, job called build. It will read in from its outputs, the matrix over here. And so that's why I like here, when we say like the step set matrix out among of a list of outputs, which is this part of GitHub output, the entry from the output list that has the name matrix. So there's matrix like mentioned a bunch of times. So I'm just going to annotate this because some of them don't have to have the same name called matrix, but some of them do. So sorry. Let's see. This one over here, this matrix has to match that one. Then this matrix over there has to match this one. Then the name of the step has to match that name. And finally, this over here will have to match that. So the word matrix is being used in many places, but there's basically 4 different pairs of how they are linked to each other. And so if you do that, now you have the job build over here, determining how the job test is being run. Now, the matrix, the strategy matrix that we see on the second job on this GitHub Actions workflow over here, that specifies a matrix of conditions of which you want to run your job. So let me take a little screenshot of this, so we can use it later if needed. So how does that influence things? So we go back and look at the older version of how this GitHub Actions workflow was. Here we have Under strategy, we're saying we want to have a matrix of configurations such that we run the same code across a bunch of parameters that we're going to change. One of them was we want to run it on the operating system called Ubuntu latest with R version 4.4, Bioconductor version 3.20, and this is the name of the container plus the name of the RStudio package manager URL. Then we also want to run it with like Mac OS latest with a version of R and Bioconductor, and lastly with Windows latest. So this is how we were able to run the exact same code for testing the package across the 3 operating systems without having to like write the same code like one time for Ubuntu, one time for Mac, and one third time for Windows. So this allows you to not have to duplicate code, make the GitHub Actions workflow like easier to write, easier to maintain. However, as it's like hard coded here as like, just specified as text, if you wanted to change this code to run then on like back on the R version 4.5 and Bioconductor version 3.21, then you need to like come here and edit these options manually. So this was part of the things that you had to update after every single Bioconductor release. So as we have it now, I created this job called biocthis config, which will run on the latest version of Ubuntu. It has an output here called matrix. I just changed the name to set biocthis matrix for the step. That's the name of this step. Again, it has the output matrix over here. And we'll see that like after a bunch of code, we eventually make this matrix of configuration with like actually like all the things we need, which is like we want to run it on the operating system Ubuntu latest with a specific R version, with a specific Bioconductor version, and a specific container. Then for Mac, we want to run it on a specific R version with a specific Bioconductor version. And finally, for Windows, we want to run it also like a specific R version and a specific Bioconductor version.
Excuse me, Leo, only the configuration for Ubuntu requires the content.
Yeah.
Yes? Okay.
Yeah. So that's the only one that we're going to be using a Bioconductor Docker. Cool. So, I'll explain later like how we come up with all these options. But the point here is you create this JSON file, JSON syntax for a set of options. And then later on, our job that's called build check will depend on the one called biocthis config. It's going to read from that biocthis config the output called matrix, and that replaces this stuff about setting the options. We need to run this first, such that later on we can say like, okay, now where does this job run on? Well, we're going to set it to the config operating system option from this matrix that we define over here, this strategy matrix. So this makes it such that like, okay, we just need to set this option over here, Bioconductor version at the top, and then that will we'll have some code inside of the job biocthis config to figure out what's the right container, what's the right R version, what's the right Bioconductor version based on these options over here. Yeah, this dynamic matrix configuration was something I did not know you could do. And once I figured, I was like, oh, this could actually unlock that bottleneck that we had before. Boom. So the rest of here, I have like several links to explaining like pieces of how some things were implemented. So one thing that I had also been tracking, keeping an eye on, that also like helped unlock a little piece or gave me a hint, was this this issue thread on GitHub, where basically r-lib actions, which is this GitHub repository. This is the where we get R for Windows and where we get R for Mac. on the GitHub Actions workflow that we're going to be using for testing. However, there was a bit of an issue where you might have this environment variable called r-lib user, but it basically wasn't creating a directory. And so if we look over here at this commit message, this commit by Gabor Sardi, he just added this thing where like, you have the environment variable called r-lib site or r-lib user, let's create that directory. And that like helped like solve a little bug. And I was like, oh, we could probably be using this r-lib user environment variable a little bit more. And how does that come into play? So let's look at how I was doing some things before. Let's see. Let me just, sorry. What I'm going to do is I'm going to actually find the code before that change, because that'll be a little bit easier. This is before I made that commit. So before, I had this set of lines from 103 to 117, where there's two pieces of code that are basically duplicated. One of them was if you're not running on Linux, then run this set of code. The other one was like, if you're running on Linux, now we have to set this other code. And the code is almost identical. The thing that changes is the path here. So in one of them, I was saying like, okay, I want to cache where the user is installing all of their R packages. And this was enabled on Mac and Windows, which is the version that depends on r-lib actions. However, the version that runs on Linux, which is the version that runs on the Bioconductor Docker image, doesn't have that environment variable set. So it was working on this other location. And so it was just like a tangential reminder that like, maybe what I need to do is on Linux, I just need to create that environment variable. So Linux here, I'm going to say like, okay, I want to create that environment variable. I'm going to specify a directory for it. I'm going to save it as among the variables that we have on the GitHub Actions workflow. Plus, I'll also make that directory, emulating what Gabor Sardi was doing on that other commit message that I showed. Once I have that, then I can just have a single restore R cache section of code that works on this environment variable, and it works for all three operating systems. So that was one change that I made that way. Here, I know I'm showing you like the commit message where everything got changed. So it's a little bit hard maybe to see. So let's look at the actual biocthis repository, how this actually looks right now. So here in lines 127 to 133, I create that variable, I specify a path for it. Then I basically set that variable over here on the GitHub environment. I also create that directory. And so later on, I can just have a single code chunk for caching the R packages instead of having two, because this path is set to that r-lib user environment variable that we have. So that's something else that I was like, okay, that can help change a little bit. Another thing we had before is that this cache keys for basically a GitHub Actions workflow, if it's successful, it will save some files that we can use in the future. I was setting those keys here with like hard-coded names, saying like this is the bioconductor release R20 version with like this specific R version 4.4, etc. So this was also some of the lines of code that had to be updated every time you every time there was a new bioconductor release version. And so like I know that explaining this to a few of you, like it was a bit of a source of confusion. Why are we having to change this? How does this really affect the GitHub Actions workflow? So now I decided to change all of that to just say like the key is going to be the operating system dash the version of R dash the version of Bioconductor. And you can also specify a cache version if you want. So now this code is a lot more static across Bioconductor versions and stuff like that. So that was one source of simplification of the code, making it like more automatic instead of hard-coded values here on the YAML file. So that's this little step over here. Now, looking at things, I realized that the remotes R package, they have this commit from about 3 weeks ago, over here, 3 weeks ago, where they have this function called system requirements, which is a function that you can run on an R package, and it will tell you what are the system requirements for Linux that you need to install. And I saw that like 3 weeks ago, they added support for Ubuntu version 24.04. Why does that matter? Well, on Linux, the version of Ubuntu that we're using is 24.4, 24.04. And so like in the very near future, I'm going to be able to update the GitHub Actions workflow over here to actually automatically figure out what are the system dependencies that the R package needs on Linux and be able to install them automatically. That's something that we used to have support for, but because once the Ubuntu version changed and remotes wasn't able to support that version, I had to stop that. And so this is these lines of code 152 to 160 that are currently commented out, where we could have a step called install Linux system dependencies. And what it does is that it runs in R, basically this remote system requirements with that specific version of Ubuntu. Now, if you run it right now, you get an error. And that's because the CRAN release version of the remotes package hasn't implemented this update yet. And so like we need to wait a few more weeks before this new version of remotes makes it up to CRAN. Right now it says like, well, you're not specifying any of the valid options. That's why like this is an error. So that will be something nice in the future, where you can like automatically figure out what are the system dependencies that you need on Linux and just install them. So that's like, this is an example of things that like I'll change in the GitHub Actions workflow from biocthis that you might want to then like actually update yours, which is kind of independent from all the updates related to Bioconductor versions across time. So that's a little peek into the future. Now, let's go back to looking at some of the code for making these matrix JSON syntax. So this is the code for actually figuring out what version of Bioconductor we're going to be working on. And so first of all, I needed to figure out how can I take a web file over here, such as this one. This is a file that Bioconductor hosts that specifies all of the versions for R and Bioconductor. And so this little file is used by a bunch of things that, like for example, the biocthis manager package for installing versions, a bunch of other Like this file is also used by RStudio, Package Manager, and a bunch of other places. And so let's look at what this little file has here. So it says like, has this option called R version associated with release, R version associated with develop. So that's pretty cool. Like if we want to be running with release or develop, this is where we can figure out what are the R versions that we need. It also says like, what is the bioconductor develop version? In this case, 3.21. What is the release version, which in this case is 3.20. So there's a bunch of things here that we can extract from this little file on the web. Our job over here called biocthis config, I set it to run on the latest version of Ubuntu. These loads basically like they have some machines already set with this version of latest version of Ubuntu, so it doesn't take any seconds to set up anything. So right now, imagine we're working on a Linux machine that doesn't have R, doesn't have anything else. So I can't really use the biocthis manager package to tell me like what's the release version of Bioconductor or what's the developed version of Bioconductor. Because if I want that, then I need to install R, and that can take around 55 seconds or so, 50 seconds or so. So I don't want to like spend resources unnecessarily. So I'm like, okay, I have this file over here on the web. How can I read it and like store it in a variable in Linux? So going around, I saw that like this answer over here for storing the contents of a file read from the web. And if we look at what this person responded, they said like, well, you could either use the wget command or the curl command with this L option. Run it such that like you store the contents of the output with the $, open parenthesis, close parenthesis syntax. And in here, they're creating a variable called content. If you want to look at what it has, you just echo the variable. So I was like, okay, that's pretty cool. So if we run this also, let me actually log in into an actual Linux machine instead of mine over here, my Mac machine. So if you run that, I created this like a variable called biocthis. So if you echo it, there's a little bit of a difference between echoing on Linux versus how it works on a Mac computer. So echo on a Mac computer actually returns the file with like all the new line, being actually respected. Whereas on Linux, this was something I figured out later, which is like actually if you want to include the new lines, you have to use the quote symbols. If you do that now, you do get like the lines being respected. Cool. So at this point, we have a variable called biocthis that has all of those contents from that file on the web. And so now we're like, okay, let's say we're working with biocthis version set to biocthis release. So this is like from the options over here that the user specifies, or working with that biocthis release option. In that case, then I know that we saw that there was this option called release version. So we can search for it with grep. Find that little line that says release version. Now that we found the line, I need to somehow be able to extract the numbers here, 3.20, the numbers and the period, 3.20. And so that led me to another little search for options, which led me to this grep on a variable to keep only the match. And so,
sorry, could you say that again?
I don't want to say that. And so we see here that this answer that says like, well, you can use the -o option on grep to just keep the match. So I was like, okay, now I know how to keep the match, but how do I actually search for just the numbers with the period? And so I had to be like, okay, I want to search like a pattern that has some numbers. So I need to learn what was the reject syntax on for grep on the Linux terminal. And so if you use the -e option, you can specify a regular expression. And you can say like, I want a number, which is this square bracket 0 to 9. And then you can say like, how many numbers of them do you want with the inside of the curly brackets. So using that syntax over here, I'm like, okay, I want to search for, a number here, a single number. That's why I have it in curly brackets 1, followed by a period, followed by 2 numbers. And I want to keep just that value. And so this is how I get this 3.20. So now we know the bioconductor release version. For getting the R version, again, I go back to our biocthis variable that has the contents from that file on the web, and I search for the line that says R version associated with release, colon, and then the space. And so that says, okay, now I have this line. And in this case, I only want to get the X and the Y numbers. I don't want the Z. So again, I use this grep syntax, and I'm like, I want a number, a period followed by a number. And if I run this over here, I can copy it, sorry. Copy, paste. Boom, I get 4.4. So now I have the bioconductor version, the R version. But in the case of release, for specifying the container name is going to be bioconductor/bioconductor_docker :release_, and then the major version number _ the minor version number. So now I need to like cut pieces of the bioconductor version. So biocthis version, like I have here 3.20, I need to separate the 3 from the 20. So I'm like, now I'm using the cut command, where I say like, I just want from the first character up to the first character, and then I want from the third character up to the fourth character. So now that's how I get the major and minor versions, and I'm able to create this little string that will have the container name. So that's how it looks over there. So now I have all the options I need for bioconductor release. What happens with bioconductor devel? Well, it's really a very similar process where now I search for the line that says devel version, as well as R version associated. I find the biocthis version. This is 3.21. I can also find the R version associated with the developed version of bioconductor. However, what is the challenge here, right? I found the number 4.5. You should think like, okay, I'm set. Well, I'm using r-lib's actions for setting up R on Mac and Windows. And like r-lib actions, sorry, let me find you the exact page here. R-lib actions for this set of R, you can specify here the R version. You can take release, you can take devel, or exact numbers. However, in this moment in time right now, before April, R 4.5 as a number is not provided by CRAN. they just have it under the label devel. So if I say like, hey, I want to download version R4.5, this r-lib actions cannot find it. So I need to actually say like, in this moment in time, I really want the devel version of R, not the R4.5. So how do we resolve this? Well, if I find what's the current version of release, for bioconductor release, if these two numbers do not match, then I want the devel version. If they do match, then like I'm okay with having a little number. And so this becomes a little bit tricky because R is updated once per year in April, whereas bioconductor is updated twice per year, once in April, once in October. And so this is not always a perfect match. You can't say like, I always want the R release version or I always want the R develop version. That doesn't work either. So I need to actually say like, okay, get me the R release version, get me the R develop version. If they match, then I'm okay with using just that number that we got for our version develop. Otherwise, what I really want is a develop version. All this is a little bit complicated, but like that's how I get that name. Now, since we're like on the develop version of bioconductor, then like the name for that container is specified as devel. They provide that fairly easily. They don't provide like like the latest release, like colon release. That doesn't exist. You have to use this other syntax that we saw earlier, which is the capital release underscore number underscore another number. So like all these things are like involve like it's almost the same information, but you have to put it in like very, very right format for things to work. Let me run all the internal code for the develop version. Sorry, I copied too many lines. So once we found all those settings, these are the settings right now if you wanted to use our bioconductor develop, which is the version is bioconductor version 3.21. The R version is going to be develop. And then we find the Docker name, which is that name over there. Boom. The easiest option then was like, what if you say just a number? What if the user just says like, I want bioconductor 3.20? At that point, a lot of this has become simpler because you're saying like, okay, that's my version. Then actually, sorry. It's simpler and not simpler. Sorry, I forgot something that gets a little bit tricky, which is, let's look at that YAML file that has all the things. So this file that bioconductor provides has at some point this thing called R version for bioconductor version. And it has like on the left side, the R version. Sorry, the bioconductor version. This is the bioconductor version. And then after the colon, you have the R version for it. If we look at this file, we will notice that all of that is contained between R version for biocthis version and release underscore dates. So in those lines of code, that's where we have all these options specified. So I needed a little bit of help, which is how do you find the lines between two patterns when you're searching? And so the answer here when I looked around was you can use the SCD command to say, I want the lines between these parent AAA and CDNN in this case. So here we get like all those lines. In our case, we want all the lines. Let's say we're working with biocthis version 3.20. I want all the lines between our version for biocthis and release underscore dates. I want all of them. So we can run that. And I'm able to now narrow down to just this set of lines that file has. Now that I'm inside of those lines, now I can search for our bioconductor version number. Oh, sorry, IC version was 3.20. So now out of all those lines, I find this line that has 3.20 followed by a colon, sorry, a quotation, a double quotation, followed by a colon. So that's what is shown over here in red. So now I found the line that I'm interested in, and after that, I want the numbers on the right side. So I need to now use a grep for finding the numbers that are on the colon, space, double quotation, the numbers after that. Once I found those numbers, then I just want the 4.4. So this line of code is like super long because it involves a bunch of pipes, but eventually I'm able to find the R version for the corresponding bioconductor version. Technically, if you specify one bioconductor 3.21 right now, this would crash because it would tell you that our version is 4.5. And then since that version is not released by CRAN yet, then r-lib's action breaks. But like, if you really want the develop version of bioconductor, when it's developed, you should be setting it to biocthis develop over here, not the version 3.21. So that's just an edge case that is not supported right now. Cool. So now we have the bioconductor version, which is a user specified, where we're able to extract the R version, and then we can just as we did before, we can construct the Docker image path. So let's say we're working in that scenario. We run all of these things, and now we can see like what are the settings that we found. And so we found that like for 3.20, the R version is 4.4, and this is the Docker name. So all of that was a bit complicated, but now we have 3 different settings supported, 3 options that the user can specify: biocthis release, biocthis develop, or a number here like 3.20. Once we have that, then we actually have to create the JSON syntax here. And so doing this wasn't the easiest thing because you have to like create a JSON file like in a single line. And so it's easy to make a bunch of mistakes. If you're missing a quote, if you're missing curly bracket, etc. So what I used there was like I would create it, but then I would test it with the JSON Lite package. The JSON Lite package here has the functions to JSON if you want to create a JSON file. So like I did a little test from R, specifying like what I really wanted to then see how the syntax should look with all the curly brackets and all the quotations and all of that. But then it also has another function called from JSON. So then that's how I would ran it and then test is my JSON syntax valid or not? That's the way I did it. I imagine that there's other websites where you can just put some JSON code and check is it correct or not. Cool. So I already specified this thing about finding the right R version for release. And like, I didn't remember that I had already done this with R in the past, but that's syntax. Something related is also like, there's the RStudio package manager, and they have a website where you can find the setup for Bioconductor. You can change which is the operating system you're working on. You go to Mac, for example, it will tell you like, hey, you need to set this environment variable called cran to this value over there, etc. If you want to use the RStudio package manager. I gave it a test, but actually I ran into an issue where on Mac, it wasn't able to install the XML package. So then I went back to like what I was doing before. Now, something here that can influence where you install packages from is whether you set the cran environment variable or not. So r-lib actions, which I've mentioned before, today we were looking at the R version input, but later on it has something called cran, and this specifies what cran mirror to use. We can see this in the log files for our GitHub Actions workflows. So let's look at, for example, the set by a C version step. We click here on the little triangle, we'll see what are all the environment variables that it had. Now, if we go to Mac, set by C version, click on that little triangle. We can see what are the environments we have here set up. We see here at some point, it prints out what is the cran location that it's using to install the packages from. And so like, there's been a lot of movement in our community to try to create more binaries for our packages and include binaries not only for Windows, which is the operating system where binaries first started to, or like one of the first operating systems that had binaries for. But now there's also binaries for Linux, for example. And so how does this reflect on the user? Well, this reflects on like how fast you actually install all the dependencies that you need to test your package. If there's binaries available, it will like install like super fast. Whereas if he has to compile them from source, and it will can take depending on how many dependencies you have, it could take like up to like an hour, let's say, of compiling dependencies. As a user, that means that like you make a commit, you push it, and then you need to wait like an hour to figure out like whether your change broke things or fixed things, right? So that's a lot of time that you need to wait for. So we want this to be as fast as possible. And so that's why I tried using the RStudio package manager a little bit directly, but it turned out in my test that it was actually best not to use it. Some of these things that where you specify just the global, cran.rstudio.com, it ends up finding the binaries in some scenarios. So I didn't find this that useful. However, as we know on Linux, it's a little bit different. On Linux, it's a little bit different because I'm using the Docker image from Bioconductor. And so there on Linux, on this step where I'm setting the r-libs user, I also say like, hey, I actually want to specify, in that case, the cran environment variable. And I'll be using the package manager from Posit available for Linux. Go back here, say I want Linux. We know that we're working on Ubuntu 24.04. The short name for that version of Ubuntu is called Noble. And so among the things here it has, it says like, you want to use a cran, you want to set cran to this URL. So that's what I did in the case of Linux. Those are some of the changes. Eventually, I decided, well, I don't really need to set that the Linux machine was already working well. So I removed those lines that I was showing you about the CRAN environment variable. Now, I'm explaining that because maybe in the future, you really want to control what CRAN mirror you're using. You have to do that here, right? Basically have that little line of code that I was showing. These options, repo, CRAN, put it in your R profile. Do that on Linux. And then for the other ones, you could just say among the environment variables, what is your CRAN going to be like, right? So you could say, put something there. And then r-lib actions will use that. So if you really wanted to set the CRAN mirror, that's how you could do it. This might be relevant if, let's say, you're working with R packages that are not publicly available, that you have them on a specific repository internally. You might need to specify the URL for that. And then also do a few other things so that you get access to your private repository, right? So that's a bit more advanced than what I'm doing. Cool. So that's all the details behind this update to biocthis version 1.17.4. If you have an R package and you want to test things with GitHub Actions workflow on like these 3 operating systems, that's how you would do it. Now, I did add this little comment over here that if an operating system is failing and you don't want to test it, you basically have to manually remove those lines from here related to that. So let's say like macOS is failing, I will need to remove here from the comma before macOS latest up until like the end for this comma for Windows latest. So this is a little bit harder than it used to be. It used to be just different lines. It used to be different lines here, and you could just, in the past, you could just put a little pound sign before it, right? And then you could basically ignore one of the 3 operating systems if you needed to. This is something that a lot of times you might need to do if you're working with Bioconductor devel, and like there's a package that is like not being able to be compiled because it has some bug, and then this actually happens frequently on the Mac version. So a lot of times you might have to like comment that out. So this is that is a little bit more painful than it used to be because it's all in this like super long line of code. Here, line 88, right, is part of this whole big thing. So there might be ways of I guess adding like an option here of like what operating systems you do really want to run. Based on that, maybe changing how this matrix configuration looks like, right? But yeah, that's maybe something for a future feature, right? Cool. So yeah, this explained like all the changes that we were seeing. Sorry, trying to find. Yeah, all the changes that that would happen if you run this function again from biocthis on your existing package that has a GitHub Actions workflow made by biocthis already in the past, as is this example with a special IVD. So you'll see like a bunch of lines changing, and this explains the source of those lines changing. So now you could like I would still recommend that like after you run this function that you check the git diff to make sure that like the lines of the lines that are changing are these ones. There might be other changes that maybe you had already had manually specified some, let's say some Mac OS system dependencies, or some other things that you had already configured specific to your actual package. That, like, if you run the function again and overwrite the file, you will lose those things. So you might still need to understand some of these changes that this specific version of biocthis is implementing, so you can differentiate the two types of changes. Cool. So with that, I'll stop the recording. Thank you.